All right, Dr. H here, hiking down to creek near where we live in the San Bernardino Mountains with my daughter Natanya. Say hi.
Hi.
All right, so we are going to go down and do a little bit of fly fishing. Try to maybe catch some trout in the creek. So anyway, here we are going to talk about physio on the go, right? So physiology, we're out and about doing stuff. So working on our new video podcast. And I'm Dr. H, and I'm a professor of physiology, anatomy, and pathophysiology. And one of my students actually suggested, why don't you record a podcast and talk about physiology? There's not a lot of good physiology podcasts. And I said, well, I don't think I really have time. But they suggested, well, why don't you just do it while you're hiking around or running around or doing all the things that you do anyway. I said, well, that makes sense. So here we are. Physio on the go, is the name of our video podcast. So you found us here, hopefully. I also do have a YouTube channel that we're building up called Physiology Fundamentals with Dr. H and at Dr. H Physiology. So track me down there as well. So anyway, we're walking down this hill. So while we're walking down the hill, I thought I might talk about muscle contractions. We all know what muscles are, and their job is to contract. But usually, when you think about something contracting, what do you think when you hear something contracting, Natanya? Have you heard that word?
Yeah. It gets small.
Yeah, something gets smaller, shorter. Yeah, so, and that's what most of us think when we talk about muscles contracting is, the muscle getting shorter. Well, it turns out that that's not always true. So when we have our muscle contract like this, then our bicep muscle here is getting shorter, okay? That's called a concentric contraction. That's the one we think about, okay? But we're walking down the hill here, right? So when I plant my leg and go like so, when I'm walking, I have to contract my quadricep muscle or I'll fall on my face, But when I'm doing that, when I'm contracting my quads, when I'm walking down the hill, my quad is actually getting longer with each step, okay? So that's called an eccentric contraction, all right? So we have concentric contractions and we have eccentric contractions. So when we say contraction in physiology, we got to be kind of careful. We can't just say, well, it's getting shorter, because it might be, or it might be getting longer. So what does it mean to be contracting then? Well, what it means to be contracting is the muscle is generating some force. That's what it really means. Now, if you're generating more force, gotta get this out of the sun. So if we're generating more force than is being pushed against the muscle, it does get shorter. But if you generate less force than is being pushed against the muscle, it can actually get longer. And it's also possible here, can you hold that for a second? All right, so if we have a situation where we have muscles contracting with equal force, like I'm doing here, okay, then we're generating force, so it's contracting, but the muscle's not getting shorter or longer. So that's called isometric, right? You've probably heard of isometrics as a way of working out, right? But isometric means same length, okay? So an isometric contraction is one where the muscle generates force but doesn't change length. So muscle contractions, and we got three kinds. We got concentric, where the muscle does get shorter. We have eccentric, where the muscle is generating force but actually getting longer. And then we have isometric, where it's generating force and not changing length at all, right? Well, these are three different types of contractions. What do they all have in common? The muscle is generating force. Well, how does muscle generate force? We might want to ask, okay? Well, inside the muscle cell, we have these things called actin and myosin. And they work together. So the myosin actually is a molecule, a protein, that grabs onto actin and pulls on it. Okay? And it uses this energy source called ATP. I'm sure we've heard of ATP. ATP is the molecule you make in part of your cells called the mitochondria, the powerhouse of the cell. Have you learned about the cells this year a little bit? Not too much. Well, Dad's not doing a very good job teaching the homeschool. So we're doing that now. So inside of your cells, you have these things called mitochondria. And they use oxygen from the air we breathe and glucose from the food we eat floating around in our blood to make this stuff called ATP. And ATP pretty much powers everything in our bodies, right? So if we need a power source, a fuel, like a car needs gasoline, we use ATP, right? So, with our muscles then, the myosin actually uses up some of that ATP to get some energy and pull on the actins. And if that's shortening the muscle, that's a concentric contraction. If that's lengthening the muscle, it's an eccentric contraction. And we gave a couple of examples, but another example, trying to get this so I'm not in the sun, there we go. Also try not to fall on my face while we're walking down the trail. So another example is walking down the trail versus going up the trail, right? So right now we're walking down the trail, and mostly I'm using my quads with an eccentric contraction. It doesn't take a lot of force because we're going downhill. So the rest of my, my calf muscles and so on, they're not used a whole lot going down the hill. It's mostly absorbing energy in my quads, in the form of an eccentric contraction. So something interesting about eccentric contractions is that they don't use much ATP. Concentric contractions use a lot, but eccentric contractions don't use much. And there's various ideas behind that, and we won't get off into that. When I was a when I was a PhD student, University of Arizona a few years ago, well, more than a few years ago, but that's all right. So I was studying under a guy named Dr. Stan Lindstedt. He was a cool dude, and he was interested in this eccentric contraction business. And because eccentric contractions have two kind of unique properties. First of all, you can actually generate way more force with an eccentric contraction, like we're doing now, going down the hill with my quads. It doesn't require much ATP. So in terms of like running mountain trails, which I do most of the time. Today is a bit of a rest day, I guess. We're going fly fishing. Yesterday, ran 15 miles up the top of Keller Peak locally, and we got about 4 more in with Natanya before that, right? Anyway, I like to run trails. I do actually a lot of ultra marathons, so we're trying to get in shape for some of those. So today we're using a little selfie stick that I found in the shed to do this recording, but I'm not going to carry one of those on a run. But hopefully in future videos, I'll take you guys along on some runs with me, and we'll chat about physiology then. All right. But anyway, in running, when you're going up the hill versus down the hill, there's several differences, right? First of all, when you go up the hill, it takes more energy out of you, right? So what does that mean? Well, according to physics, when you're going up the hill, you're not just going forward, but you're going up. You're working against gravity. So you are actually creating what's called potential energy by the fact that you're going up. And you could turn around and go back down and regain some of that potential energy, right? And so when you're going up the hill, you have to do a lot of work because you're working not only to go forward, but to go up against gravity. And when you're going up, like right now, if I'm stepping up on this little bump here, when you push up, now you're doing a lot of concentric work in my hamstrings and my glutes, and then ultimately in my calf, if I can get that, right? To propel yourself up the hill. So when you're going uphill, you're using a lot of concentric contractions, shortening contractions. What do we know about those? Well, those require ATP, a lot of it, a lot more than eccentric contractions, okay? So when you run up the hill, you got to make a lot more ATP, yeah? So what does that mean? You're going to be breathing a lot harder, and your heart rate is going to be a lot higher. Maybe one of these days when I'm out running around, we'll look at that, right? But why is that? Because when you have to make a lot of ATP, that requires a lot of oxygen and a lot of fuel, like glucose. And the only way you can get that is to breathe more to get the oxygen and pump more blood to deliver the oxygen and the glucose to your muscles, right? So when you are running up a hill, you breathe more and your heartbeat is higher because you are sending more oxygen and glucose and such to your muscles so that they can make more ATP because they're doing concentric contractions. So, and we have to do all this extra work when running up the hill because we are working against gravity and storing up potential energy. Now what about when we turn around and come down the hill? Well, when you run down the hill, you're mostly using eccentric contractions in your quads primarily, okay? And so what do we know about that? That does not require as much ATP. So you don't have your heart rate going up so high when you're running down the hill, even if you're going at the same pace, okay? And you don't breathe as hard when you're going down the hill, even if you're going at the same pace, right? Because A, you aren't generating potential energy now, you are regaining some of the potential energy that you got from running up the hill. And B, we're using eccentric contractions and not concentric contractions, okay? So kind of a fun, interesting thing to think about. Now, the other thing about eccentric contractions, I said two unique properties. One, you don't use much ATP, so we don't breathe hard, we don't have a high heart rate going down the hill, but they actually generate way more force than concentric contractions. So you're capable of generating a lot more force in an eccentric contraction than in a concentric contraction. So what that means is it puts a lot more stress on your muscle, because when you're running down the hill, your quads are basically absorbing all of that, or at least some of that potential energy that you gained by going up the hill. And they're having to absorb all that. And it puts a lot of stress on them. And that can cause a lot of muscle damage. And that can cause you to get pretty sore, right? I know from experience, I've done a number of 100-mile races, like 5 at this point that I've finished anyway. That 100-mile race meaning running for 100 miles through the mountains. And I can attest that at the end, sure, you're tired, so going uphill is tiring, but running downhill is painful. Worse, probably, than going up the hills at the end, because of the nature of the eccentric contraction, and all that force on your already blown out quads is a lot, right? So that's eccentric contractions generate a lot more force, but they can, cause a lot of muscle soreness. So when I was working for Dr. Lindstedt in Flagstaff that one summer, he had this cool bike and it was hooked up to a motor, and the motor, a duck just flew out of our little creek right here, so that's interesting. So should we try to go back to the same spot that we were? Probably. Yeah, let's go back over there. So here, while we're here, let's I guess I can't turn this around while I'm recording. That's kind of weird. Anyway, well, we'll just turn it around this way. So here's our little creeks. Deep Creek, near where we are in San Bernardino Mountains, but we're gonna cruise across this little part of it. Cruise across this little part of it, hopefully not dropping my phone in the creek. That would be a bummer. So, alright, we are across. Alright. So, now, anyway, back to the eccentric contraction thing to try to wrap this episode up, because we're about to roll into a nice little fishing hole up here to try to catch us some wild trout. Yeah. So anyway, Dr. Lindstedt had this bike with a motor, and what it did is it made the pedals turn backwards, and you would try to stop them. And if you think about that for a minute, that creates an eccentric contraction, especially in your quads. And so, yeah, he told me, I don't care if you work out on it, no problem. Just take it easy the first time, because you're going to be super sore. And I was like, oh, come on, I can handle it, right? So I got on that thing and cranked hard for like an hour or something. And now you don't breathe hard when you're doing it, right? Like I said, it's not as much of a cardio workout, but it's a muscle workout. And a couple days later, I was so sore that I could barely walk, right? So, eccentric contractions. Running downhill, skiing when you're going downhill is an eccentric contraction, same story. When you ski, especially haven't done it for a while, you don't breathe hard going down the hill, but your quads get pretty sore. All that is eccentric contraction stuff. So always, as part of my training for a big ultra, when I was first doing this, I focused only on running up hills, but I also try to make sure I pay attention to running hard down some hills. So here, let's get a view of some of the nice scenery we got going on here. Yeah, beautiful. All right, what a nice evening. Okay, it's May here in the San Bernardino Mountains, and nice time of year up here. So yeah, eccentric contractions, absorbing a lot of energy, not requiring a lot of ATP, but putting a lot of stress on your muscles. Now, one last thought, as we are almost here. I'm going to try to fall on my face on the phone here, but okay, sorry, falling through some trees and stuff. Because of all that force you generate on your muscle, you cause a little bit of damage to the muscle. And one of the theories behind what causes your muscles to get stronger is when you damage the muscles, when you're exercising, let me find a good spot here to wrap this up. When you damage them, the muscles from exercise, then they grow back stronger. And so with eccentric contractions, you actually are going to cause more muscle growth, right? So it helps build up the quads, especially to run down those hills, right? So I don't know if we can see our, where are we at here? destination. I can't really see it too well there, so maybe I'll try to make it down this this little set of rocks without breaking my neck. So yeah, anyway, with the eccentric contraction, whoop, you generate a lot of force and you'll make your muscles sore, but then they get stronger, and after a few bouts of that you get less sore. Okay, so we're just walking down this last little bit. I'll get down here and show you our nice little fishing spot, and then I'm gonna sign off, and hopefully Natanya and I will catch some dinner. But to sum it up, with muscle contractions, what does it mean to have a contraction? First of all, you are generating force. Do not just think about muscles getting shorter, because that will not always be the case. Okay, so some of the time when you're contracting your muscles, they're not changing length, and some of the time they are getting shorter, and some of the time they're getting longer. So we have concentric when they're getting shorter, isometric when they're staying the same length, and eccentric when they're actually getting longer. And then we focused a little bit on the eccentric because most people aren't super familiar with that. Eccentric contractions don't require lots of ATP, so you don't have to breathe hard and your heart rate doesn't have to go high, so it's not great cardio work like running down the hill, but it puts a lot of force on your muscles, so it will make you stronger and get those quads built up, and hopefully you'll be able to crush the downhills and the uphills when you get out and go for a run while you're listening to this. All right, so I hope you enjoyed this. It was actually kind of fun to talk about and cruise along with Natanya here, but we're gonna go try to catch some fish in our little fishing spot here near the house. Yeah, I just saw one jump a second ago, so hopefully we will do that. So take care and God bless, and we'll say bye. You can say bye to everybody, Natanya?
Bye.
Okay, take care.
Thanks for watching Physiology Fundamentals with Dr. H. Please like and subscribe, and don't forget to get outside and go for a run.